The universe operates on a bedrock of fundamental laws. These are not suggestions, they are ironclad rules that dictate everything from the dance of galaxies to the flutter of an electron. We've uncovered their mechanisms, harnessed their power, and built our understanding of reality upon their consistent precision. They are the scaffolding of existence, perfectly predictable, eternally reliable. But what if the very foundations of these laws are built on an unsettling void? What if the universe is running on rules that have no deeper explanation, principles that simply are without a discernible y*? This is the profound paradox at the heart of reality. In the quantum realm, certainty dissolves into probability. The Born rule, a cornerstone of quantum mechanics, dictates how we calculate the likelihood of observing a particular outcome when a quantum system is measured. It accurately predicts the statistical distribution of particles, guiding the design of lasers, transistors, and every quantum technology. Without it, quantum mechanics, the most successful theory of the very small, simply would not function. It is a formula of perfect predictive power, tested billions of times. The Born rule is not merely an approximation, it's a fundamental axiom. Experiments confirm its predictions with astounding accuracy, validating its place as a universal truth in the quantum world. Yet, beneath this mathematical perfection lies a profound void. We have no deeper explanation for y*. Reality should be governed by probabilities at its most fundamental level. The rule tells us how to calculate the chances, but not y*. Those chances exist, or why observation locks a quantum state into a single reality. It simply states that reality must choose from a spectrum of possibilities. Quantum particles exist in a superposition of states, simultaneously occupying multiple possibilities until observed. Wave function collapse describes the instantaneous event where this cloud of probabilities snaps into a single, definite reality upon measurement. This phenomenon is absolutely critical for our world to be tangible, for definite outcomes to exist. From the moment light hits your eye to the operation of every computer chip, collapse is a constant, unseen process making reality solid. It underpins everything we experience as real. The collapse itself is exquisitely confirmed, underlying every quantum experiment ever performed. Its predictability in terms of outcome statistics is absolute. However, the mechanism of this collapse remains one of physics' deepest mysteries. What constitutes a measurement? Does consciousness play a role? Why does information, rather than physical interaction, force this transition? It is a transition without a known cause, a fundamental interaction that simply defies a causal explanation. The very act of observing creates reality, and we do not know how. The fine structure constant, denoted by alpha, is a dimensionless number approximately 1 to 137.036. It quantifies the strength of the electromagnetic interaction, the force holding atoms together. This constant determines how light interacts with matter, the size of atoms, and ultimately, the chemistry of the universe. Its value is critical for life as we know it, shaping the stability of stars and the very existence of complex molecules. It is a number etched into the fabric of existence, observed with astounding precision. The fine structure constant is measured to incredible accuracy, its precise value confirmed through countless experiments across astrophysics and particle physics. It has been constant across billions of years and billions of light-years. Yet, its exact value remains utterly inexplicable. Why this specific number? There is no known theoretical derivation for it. It simply is a given. It exists as a fundamental property of the universe, without any underlying reason for its specific magnitude. The universe is fine-tuned by a number chosen without explanation. The electron is a fundamental particle, carrying negative charge and an incredibly precise mass. This tiny value, approximately 9.109 times 10 to the power of negative 31 kilograms, dictates the size and behavior of atoms. It influences chemical reactions, the conductivity of materials, and the very density of matter. Without the electron having exactly this mass, the universe would be a vastly different place, perhaps devoid of complex structures or stable elements. Its mass is a universal constant, meticulously measured and universally relied upon. Every experiment, from particle accelerators to precision atomic clocks, confirms the electron's mass with exquisite accuracy. This value is invariant across the cosmos, a fixed property of every electron in every galaxy. But why this specific mass? There is no theory that predicts it from first principles. It is purely an empirical value, plugged into our equations. We can describe its effects, but not its origin. Its mass is a fundamental parameter of existence, without a theoretical justification. The electron carries a specific weight, but we don't know why it carries that weight. This fundamental ratio defines the relationship between the two most abundant charged particles in the universe, protons and electrons. A proton is approximately 1,836 times more massive than an electron. This precise ratio is critical for the stability of atoms, dictating their energy levels and chemical properties. Without this specific imbalance, atoms would not form as they do, preventing the existence of complex chemistry, stars, or even life itself. It is a ratio fundamental to cosmic structure, confirmed by every atom. The proton-electron mass ratio is meticulously measured and confirmed across countless astrophysical observations and laboratory experiments. Its constancy across vast cosmic scales and eons is unquestioned. Yet, like other fundamental constants, we have no theoretical explanation for why this ratio holds its specific value. Why not 1,000 or 2,000? There is no deeper physical law that derives this precise balance. It simply stands as another unexplained input to the cosmic blueprint. The universe is perfectly balanced, but the reason for that balance eludes us. Time, for us, only moves forward. This irreversible progression is governed by the second law of thermodynamics: entropy, or disorder, always increases in a closed system. This law explains why a dropped egg doesn't reassemble itself, why heat flows from hot to cold, and why the universe expands and cools. It is an observed truth in every corner of existence, defining our perception of past and future. The universe ages, and we understand how it happens, but not why it is inherently one-directional. The second law of thermodynamics is one of the most rigorously tested and universally applicable laws in physics. Its predictions are confirmed in every thermodynamic process we observe, from stellar evolution to the boiling of water. Yet, fundamental physical laws, like those of classical mechanics or quantum mechanics, are typically time-symmetric. They work just as well backwards as forwards. The arrow of time remains an emergent property without a clear, fundamental origin. Why does the universe possess an inherent direction for its progression? The past is fixed, the future open, and the reason is a mystery. Our universe holds a profound secret: most of its mass is invisible. Dark matter, an enigmatic substance, does not interact with light or other electromagnetic forces, making it undetectable by conventional means. However, its gravitational influence is undeniable. It explains why galaxies spin faster than visible matter suggests, why galaxy clusters hold together, and how large-scale cosmic structures formed. Its effects are perfectly consistent with our models of gravity, yet its composition remains a profound unknown. The evidence for dark matter is overwhelming, derived from decades of astronomical observations and cosmological simulations. Its presence is woven into the very fabric of cosmic evolution, a necessary component for our universe to look the way it does. Yet, we have not directly detected it, nor do we know what particles comprise it. It fits perfectly into the gravitational equations, but its fundamental nature remains entirely unknown. The majority of the universe is unseen, and we do not know what it is. Even more mysterious than dark matter is dark energy, the force driving the accelerated expansion of the universe. In 1998, observations revealed that distant galaxies are speeding away from us at an ever-increasing rate, a phenomenon that cannot be explained by gravity alone. Dark energy is hypothesized to be an intrinsic property of space itself, exerting a repulsive force that pushes the cosmos apart. It dominates the energy density of the universe, shaping its ultimate fate. Its presence is undeniable, its nature a complete enigma. The existence of dark energy is confirmed by multiple independent lines of evidence, from supernovae observations to the cosmic microwave background radiation. It fits perfectly into our cosmological models, providing a consistent explanation for the universe's accelerating growth. However, its origin and fundamental properties are entirely unknown. Is it a new force? A modification of gravity? Or the vacuum energy itself? We observe its effects with precision, but have no idea what it is, or why it exerts this incredible outward push. The universe is tearing itself apart, and we do not know why. Gravity, the force that binds planets to stars and stars to galaxies, was elegantly described by Albert Einstein's general relativity. It is not a force in the traditional sense, but the curvature of spacetime itself, warped by the presence of mass and energy. This geometric understanding of gravity explains everything from the orbit of Mercury to the bending of starlight around massive objects. It is a theory of unparalleled success, confirmed by black holes, gravitational waves, and the very structure of the cosmos. Its predictions are exquisite. General relativity has passed every observational and experimental test with flying colors. It is the most successful theory of gravity ever conceived, predicting phenomena with breathtaking accuracy. Yet, the deepest question remains, why does mass and energy curve space-time? What is the intrinsic connection between matter and the geometry of the universe? Einstein described how it works, with impeccable mathematics, but not the fundamental why star. It is a profound description without a deeper explanation. Mass warps reality, yet the reason remains a profound secret. At the pinnacle of our cosmic enigmas lies the cosmological constant problem. Quantum field theory predicts that the vacuum of space should be teeming with the virtual particles, giving empty space an enormous intrinsic energy. This vacuum energy should exert a powerful gravitational effect. However, the observed vacuum energy, which we identify with dark energy, is incredibly tiny, yet non-zero. It is a catastrophic mismatch between theoretical prediction and observation, possibly the greatest discrepancy in the history of science. The existence of vacuum energy is a robust prediction of quantum mechanics, a theory confirmed to an astonishing degree of precision. Yet, the calculated value is roughly 120 orders of magnitude larger than what we actually observe as dark energy. This is not a small error, it is a fundamental breakdown in our understanding of the universe. It suggests either our quantum theories are incomplete, our understanding of gravity is flawed, or there is an unknown mechanism precisely cancelling out almost all of this vast energy. The universe is balanced on a razor's edge, and we do not know how. From the quantum probabilities that define reality to the invisible forces shaping the cosmos and the profound enigma of vacuum energy, these 10 rules underpin everything we know. They work with perfect precision, dictating the very fabric of existence, yet their ultimate why remains elusive. Our most fundamental understanding of the universe rests on a foundation of unexplained truths. We map the cosmos, build technologies, and explore the limits of knowledge, only to find that at its deepest level, reality simply is star. It operates flawlessly, without offering us the core reason for its operation. The universe is a perfect machine, running on unknown code.